Alright, so this is the characteristics and properties of minerals. Characteristics of minerals are things that minerals have in common with one another, but there's also things that rocks and minerals have in common with one another, and those would be two of the minerals' characteristics. So rocks and minerals are both solids, and they're also naturally formed. Now, all minerals have three other things in common that are not characteristics of rocks. So minerals are inorganic compounds, meaning that the compounds that they're made of cannot be made by a living thing. They are compounds that exist in nature, but they could not be things like proteins, DNA, carbohydrates. None of those things are used to make minerals. Minerals have a specific chemical formula, meaning that the ratio of one element to another is going to be the same throughout the entire mineral, and they have a specific crystal structure. So you could have two things with identical chemical formulas, such as diamond and graphite. Both diamond and graphite are minerals, and they're both made out of only carbon atoms. However, the arrangement of those carbon atoms determines the properties of it. So diamond is the hardest substance, and graphite is a very soft substance, and the only difference between diamond and graphite is not the types of element that it's made of, but the arrangement of the atoms of the element carbon. So essentially, what you need to know is that minerals are either pure elements or pure compounds, and rocks are mixtures of more than one mineral. So minerals are pure substances and rocks are mixtures. Alright, so here are the 5 characteristics, kind of in a way that's presented with some pictures. Minerals are solid, so they are not gas and they are not liquid. So here's lava, here's gas, okay? Minerals are always solid. We cannot classify a mineral until it freezes solid. Minerals are inorganic, so they're not produced by living things. So all these critters down here, they cannot make minerals from molecules in their body. Minerals are inorganic. Minerals are formed in nature, so they're not manufactured. It's not to say that we couldn't copy nature and make something in a lab that is also made by nature, but in order to be classified as a mineral, it had to be originally made by nature. Minerals have a specific chemical formula, meaning that they have the same ratio of one element to another. So for quartz, there's always going to be twice as many oxygen atoms as there are silicon atoms. And for halite, there's always going to be one sodium atom to every one chlorine atom. They have a specific crystalline pattern. So here, all of these little tetrahedrons represent silica, which is that SiO2 that I was telling you about. And they go together in a repeating pattern. All right. So, how do we identify minerals? Well, we identify them by their color, their streak, their luster, their hardness, and their density, as well as their cleavage or fracture. So the most important of these are streak, luster, hardness, and density. These 4 are the most important. Okay, sorry, where was I? Streak, luster, hardness, and density are the most important. So, color is kind of a no-brainer. You look at something and see what color it is. Many minerals have distinctive colors and varieties of hues, but it shouldn't only be used as the only identifying test. For example, here's pyrite, which is iron sulfide, and here is gold. So iron sulfide and gold. This is made out of only one element, Au, and this is made out of iron sulfide. And so they're completely different. You can actually see that this one forms a bunch of cubes and this one's kind of lumpy, but they have the same color, and so you should know the difference. All right, streak is the color that a mineral shows when it's displayed in a fine powder, and you get a streak by rubbing it against a ceramic, unglazed piece of ceramic tile. And oftentimes the streak is a different color than the mineral itself. So here's pyrite, like from the last page, you'll notice it leaves a dark gray streak. Luster is the way that a mineral reflects light. There's two types of luster. We have metallic luster and we have non-metallic luster. So there's two types of luster. Metallic is when it's shiny like a metal, and so if it reflects light the way that metal reflects light, it's metallic luster. Then we also have non-metallic luster, and there's many kinds of non-metallic luster, but you don't need to know the different kinds. Here they are, boom, 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 okay? But you don't need to know the types of non-metallic. You just need to be able to tell whether it's metallic or not. Okay, hardness. Hardness is a very, very reliable way for determining what mineral something is. You compare its resistance to being scratched to 10 different reference minerals. It's called Mohs scale of hardness because a guy named Friedrich Moh developed it. And the coolest thing about Mohs scale of hardness is it's something that you can do when you're out in the field. So when you're out in the lab, you'll notice on this diagram in the upper right-hand corner of the diagram, it says National Park Service. So you can be out exploring nature, and you can have a masonry drill bit with you, you can have a steel nail, you can have a knife, copper penny, and your fingernail, and you can have all of these different things to test the hardness of a mineral. So if you had calcite in your hand, you'd be able to scratch your fingernail, but you would not be able to scratch a penny because calcite has a hardness of 3. And hardness, what it's telling you, it's not telling you whether or not you could break it with a hammer more easily or not. It's telling you how tightly bonded are the atoms of that compound. So the more tightly bonded they are, the more difficult it's going to be to scratch that particular item. All right, density. All right, density is mass divided by volume. And specific gravity is just using it to talk about something's density relative to water, but you don't need to know it as specific gravity. Just know density. It's its mass divided by its volume. The more dense something is, the heavier something will be, the more heavy it'll be relative to an object that's the same size. All right, cleavage is referring to the way a mineral breaks when it's just kind of tapped with a hammer. And if it breaks in flat planes that are at specific angles to one another, we say that that mineral has cleavage. So you can have all 4 of these different types in the diagram on the left-hand side. And calcite and halite are minerals that are in our mineral kits. And we could see that the halite was very cubic, and the calcite kind of has that diamond or rhomboidal cleavage. Mica is also a good example. It comes off in flat sheets. Mica was also in our rock, metamorphic rock kit. Fracture is a description of the way it breaks that is not in flat sheets. You can have conchoidal cleavage, you can have hacky or jagged cleavage, you can have uneven, you can have fibrous. But fracture is basically, it has fracture because it breaks and it's not cleavage. So basically, fracture isn't necessarily as indicative of what mineral something is as cleavage. All right, so here are some different minerals and their common uses. Bauxite, which is where we get aluminum from. Calcite is used in medicine, toothpaste, and building materials. Copper is used in electrical wire. Diamond is a cutting tool and a gemstone. Graphite, also made out of pure carbon, just like diamond, is used as pencils, and it's used to lubricate machinery. Gypsum is used for drywall. Halite is salt. Quartz is used in oscillators in electronics, computers, radios, and clocks. Silver is used in jewelry, photography, and electrical equipment. Sulfur is used in fungicides, kills bacteria and fertilizer, and talc used to be used in baby powder, but is no longer. All right, that's the end of the presentation.